Hello guys, welcome to Digit Fox Network. I am excited to have you here on our channel. Today we are diving into a fascinating topic that combines economics, technology, and the power of simulations. The Monte Carlo simulation using Python code. You know, years ago, during my time in the financial services industry, I overheard a conversation between an economist and a client discussing something called the Monte Carlo simulation. Back then, I had no idea what it was, and my attempts to find information online were quite limited. Fast forward to today, with the internet more developed and brimming with data, I was able to uncover in-depth information about the Monte Carlo simulation. And guess what? Thanks to the magic of AI, particularly ChatGPT, and the versatile programming language Python, I have even managed to replicate this simulation on a small scale right here on my computer. In this video, we'll break it down into two main sections. First, a brief introduction to the Monte Carlo simulation, what it's all about and how ChatGPT suggested how to create the Python code to set up the simulation. And in the second part, our AI guide from DigitFox Network channel will take over. They'll delve into the nitty-gritty details of the prompt and the Python code, providing you with a comprehensive understanding of how this simulation works. I am confident you'll find this simulation both intriguing and enlightening. So, without further ado, let's jump into the world of Monte Carlo simulation and Python programming. By the way, don't forget to show your appreciation by liking, sharing, and subscribing to our channel for more captivating content. Thank you for tuning into DigitFox Network. Get ready to expand your horizons with the magic of the Monte Carlo simulation. Until next time, happy exploring. So, the Monte Carlo simulation with Python. In simple words, a Monte Carlo simulation is like a smart guess that uses randomness to estimate outcomes. Imagine you want to predict something, but it's too complex to calculate exactly. Instead of trying to solve the puzzle directly, you take lots of random guesses and use them to figure out an approximate answer. In finance and other fields, Monte Carlo simulations are often used to predict outcomes when there are many uncertain factors at play. Here's how it works. First, set up the scenario. You have a situation where you are not sure about certain variables. For instance, in finance, you might want to estimate how an investment portfolio will perform over time, considering market fluctuations. Second, randomly simulate. Instead of trying to predict exact future values, you randomly simulate different possibilities for the uncertain factors. For example, you might simulate various market scenarios, each with different rates of return for your investments. Third, repeat many times. You repeat this random simulation process many times, hundreds of thousands, to create a range of possible outcomes. Fourth, analyze results. You analyze the outcomes you have simulated to see patterns and trends. This helps you understand the likelihood of different outcomes and the potential risk and rewards. Fifth, make informed decisions. With this understanding, you can make more informed decisions. In finance, this might involve adjusting your investment strategy to account for the potential risk and rewards you have identified through the simulation. In essence, Monte Carlo simulations use randomness to tackle complex problems by providing a broad understanding of possible outcomes. They are especially helpful when there is a lot of uncertainty involved and when calculating precise answers is difficult or impossible. The Monte Carlo simulation with Python. A Monte Carlo simulation can be extended to simulate the future value of a portfolio containing both US stocks and US bonds denominated in US dollars. In the Python code example shown after this presentation, source ChatGPT, we simulate the future value of a portfolio over a specified number of years using Monte Carlo simulation. The portfolio consists of both US stocks and US bonds, with defined average returns and standard deviations for each asset class. We iterate through multiple simulations, each time generating random returns for stocks and bonds using the defined mean and standard deviation. The portfolio value is calculated for each year based on the allocation to stocks and bonds. The simulation results are then plotted to visualize the potential range of portfolio values over the specified time frame. Keep in mind that this is a simplified example, and in a real-world scenario, you might want to consider more complex factors such as correlations between assets, inflation, taxes, and transaction cost. On Visual Studio Code, we need to install first the libraries NumPy and Matplotlib. First, open your command line interface, example, command prompt on Windows, terminal on Mac OS or Linux. Second, run the following command to install NumPy. pip install NumPy. NumPy, this library is used for working with arrays and mathematical operations. Once the installation is complete, you can run your Python code again in Visual Studio Code. The NumPy library should now be available.
Hello YouTube viewers and welcome to DigitFox Network. In this example, we simulate the future value of a portfolio over a specified number of years using Monte Carlo simulation. The portfolio consists of both US stocks and US bonds, with defined average returns and standard deviations for each asset class. We iterate through multiple simulations, each time generating random returns for stocks and bonds using the defined mean and standard deviation. The portfolio value is calculated for each year based on the allocation to stocks and bonds. The simulation results are then plotted to visualize the potential range of portfolio values over the specified time frame. Keep in mind that this is a simplified example, and in a real-world scenario, you might want to consider more complex factors, such as correlations between assets, inflation, taxes, and transaction costs. Let's break down the Python code step by step. Import necessary libraries. Import random. This library is used for generating random numbers. Import NumPy as NP. This library is used for working with arrays and mathematical operations. Import matplotlib.pyplot as PLT. This library is used for creating plots and visualization. Set up parameters for returns and allocations. mean_stock_return and stev_stock_return. These represent the average annual return and standard deviation of returns for stocks. In our example, mean_stock_return equals 0.08, and stev_stock_return equals 0.2. mean_bond_return and stev_bond_return. These represent the average annual return and standard deviation of returns for bonds. In our example, mean_bond_return equals 0.04, and stev_bond_return equals 0.1. Stock_allocation, and bond_allocation. These represent the percentage of the total portfolio allocated to stocks and bonds, respectively. Stock underscore allocation equals 0.7. Bond underscore allocation equals 0.3. The initial investment in our example equals 100,000 US dollars. This is the initial amount of money invested in the portfolio. The numbers of years equals 10. The number of years to simulate. The number of simulations equals 1000. The outer loop runs the specified number of Monte Carlo simulations. Within each simulation, random returns for stocks and bonds are generated using normal distributions, np.random.normal. The inner loop iterates through each year and calculates the value of the portfolio at the end of that year. Stock underscore value and bond underscore value represent the values of the stock and bond investments at a particular year. Total underscore value represents the total portfolio value at that year, considering both stock and bond investments. Portfolio underscore values keeps track of the portfolio value for each year. ChatGPT suggests also to use a code snippet to create a plot using matplotlib to visualize the portfolio performance over the simulated years. Plot simulation results. Each line in the plot represents the portfolio value trajectory of a single simulation. plt.label, plt.label, and plt.title set the labels and title for the plot. plt.show displays the plot. This code performs a simple Monte Carlo simulation to estimate the potential future value of a portfolio containing US stocks and US bonds. The resulting plot shows the range of possible portfolio values over the simulated time period. The Python code example, provided in this video, source, ChatGPT, is a simplified form of simulating many market scenarios as demonstrated through the Monte Carlo simulation. Here's how it works in that code. 1. Simulating many scenarios. In the code, the variable num underscore simulations is set to 1000. This means that the simulation will be run 1000 times, each time simulating a different scenario. 2. Randomness and scenarios. Within each simulation, random returns for stocks and bonds are generated using normal distributions. These returns represent different scenarios for how the market might perform over time. Each simulation is a unique scenario because it generates different random numbers. 3. Building portfolios. For each simulated scenario, the code calculates the value of the portfolio over a certain number of years. By doing this for 1000 different scenarios, you're effectively simulating 1000 different market scenarios, each with its own set of random returns for stocks and bonds. 4. Analyzing results. The simulation underscore results list stores the portfolio values for each scenario over time. By plotting these values, you can visualize the range of possible portfolio outcomes based on the simulated scenarios. This gives you insight into how the portfolio might perform under various market conditions. While the example is simplified and doesn't cover all the complexities of real financial markets, it captures the essence of a Monte Carlo simulation in finance, creating a range of potential outcomes by simulating many different scenarios with random variables. The code provided by ChatGPT was designed to generate a plot showing the simulation results. However, following a code customization, after each simulation, the code did print out the final portfolio value for that specific simulation scenario, as you can see here in this video. What do you think? Would you like to try as well this ChatGPT code to reproduce this simple Monte Carlo simulation on your computer? We really hope you have enjoyed this video. Please feel free to like, share and subscribe. Until next time. Take care, bye for now.